Okay, I'm on page 12 of your class packet, and I want to practice graphing these absolute value equations real quick before we move on to the last section, just to review and help you out since this was new. So we're gonna try as much as possible to use the shortcuts instead of making that input and output table like we did on the previous pages. But of course, you're more than welcome to do that because it still works in the end. So if I look at this one, I have a +3 on the outside of my absolute value sign. So outside means up or down. It's positive, so I'm gonna go up 3. That is my starting point. Now, my first number in front of my absolute value sign is a +1. So that means I can start by going over 1, up 1 on both sides, then going back to that starting point at 3 and going over 2, up 2 on both sides. And then you could go back to that starting point and go over 3 and up 3, but that will not fit. So there's my graph. That is what you would get even if you did an input and output table. It works every time. So if I do this one, for example, I have a -2 outside of my absolute value sign. So that means I'm gonna go down 2. There's my starting point. The number in front of my absolute value sign is a 1. So that means I can go up 1 over 1 on both sides, go back to -2, go up 2 over 2 on both sides, go over 3, up 3 on both sides, and so forth. Now, you just have to be careful because you got to make sure every time you go back to your starting point. Don't start from the previous point you graphed because it's going to be wrong. Next one. This time I have a minus inside my absolute value. Inside means you're going to shift right or left, and you're going to do the opposite. So since it's -3, I'm going to go to the right to +3. And there's my starting point. The first number is still a 1. So that means I'm going to go over 1, up 1 on both sides, back to the origin, or I'm sorry, back to your starting point, which is 3, and go over 2, up 2 on both sides. And then go back to your starting point, and I can go over 3, up 3 on both sides. And remember, all these graphs should look like a V. And then the next one, I got a +2 this time inside my absolute value sign. Inside means you're gonna shift right or left. It's positive, which means I gotta do the opposite, so -2. So when it's inside, you do the opposite. If it's outside, you don't do the opposite, you go down or up based on if it's positive or negative. And since my first number is +1 again, I can go over 1, up 1 on both sides, over 2, up 2 on both sides, and then over 3, up 3 on both sides. So feel free to pause the video, finish graphing your absolute value equations. Those tricks are gonna help us when we go to the next page here, because now what we're doing is we're still graphing absolute value, so it's still gonna be a V, but now it's inequalities. Inequalities means you have to have shading. So these examples down here, either everything outside your V is gonna be shaded or everything inside your V is gonna be shaded. The shaded area contains your solutions. Because when it's an inequality, you can have more than one solution. So for example, if you have an answer that says y is less than 3, well, the answers would be everything that's less than 3. Well, there are numerous numbers that are less than 3, so that's why the shading helps indicate all the answers and where they are on your graph. But first, before I even get into the shading details, we need to graph this. So for this one, I have a number inside and outside my absolute value sign. So I'm gonna try, let's just see here. I'm gonna try to use as many shortcuts as possible. So inside means you move right or left. It's negative, so that means I'm gonna go to the right 2. And I have an outside number of -1. Outside numbers mean you go up or down and you keep the sign the same. So that means I'm gonna go down 1. So I'm gonna go over 2, down 1 for my starting point. Again, my inside number was a negative, which means I'm gonna go to the right 2. My outside number was a -1, so I'm gonna go down 1. That is my starting point. Now, my first number in front of my absolute value is not a 1. Instead, it's a 3. But that's okay. I can still figure out what my shifting, my counting is going to be by multiplying the numbers 1, 2, and 3 by whatever that outside number is. 1 times 3 is 3. 2 times 3 is 6. And 3 times 3 is 9. So that means at my starting point, I'm going to go over 1, up 3 on both sides because 1 times 3 gave me 3. Go back to that starting point, go over 2. But now I'm going to go up 6. 1, 2, 3, 4, 5, 6 on both sides. And then, if I could fit it, I would go over 3, up 9. But I can't fit that on my graph. So there is my V-shaped graph. Now, I cannot stop there because this time we got inequality. I got to figure out where the heck I'm shading. The easiest way to do that is to pick a test point. Okay, a test point is just picking any point on the graph and checking to see if it's a solution or not. The easiest point to pick is 0, 0. Okay, it works as long as your V isn't actually touching the origin. If it does, you got to pick a different point. But 90% of the time, you can pick 0, 0 because that's the easiest point to plug in to see if it comes out to be a true statement or not. So that means I'm going to go back to this equation and I'm going to plug in a 0 for x and a 0 for y. So if I do that, it'd be 0 is less than or equal to 3, and then I have my absolute value signs. Inside would be 0 minus 2, and on the outside I still have that -1. That is what it would look like if I plugged 0 in for x and y. Now I'm going to simplify that. I have 0 is less than or equal to. Now, 0 minus 2 is -2. I can still simplify that. The absolute value of -2 is a +2 because absolute value always gives you a positive answer. And then the 3 is attached to that bar because there's no plus or minus in between. So that means multiplication. So what I'm left with is 0 is less than or equal to 3 times 2 because the absolute value of -2 gave me 2, and then I still have the -1. Now, order of operations tells us we need to multiply before we minus. So 3 times 2 is 6, and then 6 minus 1 is 5. So this is the statement I'm left. To read it, you start from the left-hand side. 0 is smaller than or equal to 5. Well, that is a true statement. 0 is smaller than 5. So that means if I go to 0, 0, it's a solution. If 0, 0 is a solution, that means everything on the outside of that V is a solution because 0, 0 is on the outside of the V. So everything outside your V should be shaded. Now that's your final answer. So now, let's go to this example down here. So this one, they give us 4 options. It's multiple choice. It's asking us which graph matches this inequality equation. So if I use my shortcuts to graph it, I have a number on the inside and I have a number on the outside. Inside, opposite. So it's going to go to the -4 to the left, and then it's -1, so down 1. So I got to find which starting points have over -4, down 1. It looks like A and B both have -4, down 1. So I know it's not C and D. I can eliminate those. Now, I got to figure out, are we shading inside or outside our V? So I'm going to use the test point 0, 0 again. That's the easiest to plug in. So I'm going to take that equation and I'm going to plug in 0 for y and 0 for x, and then simplify that and see if it comes out to be a true or false statement. So 0 plus 4 is 4. The absolute value of 4 is just +4, and I still have that -1. 4 minus 1 is 3. So this says 0 is less than 3. Well, that is a true statement. So that means 0, 0 is a solution. 0, 0 is outside of the V. So everything outside of your V should be shaded, which would be an answer B. So that would be the correct answer to that graph. All right, let's move on to, should we do another multiple choice one? Okay. All right, so let's do this one. So to graph it, I have a +1 in the inside and I have a -3 on the outside. Unfortunately, my shortcuts aren't gonna work here because I got this 2x. Up to this point, it was always just an x inside the absolute value, no coefficient, no number in front of that x. This time we have a 2 in front of the x. So I'm gonna make an input and output table to first figure out which one represents my correct V shape. So I'm gonna use numbers, we'll go -2 to +2, see if that's gonna be enough to work. So these are the numbers I'm gonna plug in for x and see what numbers I get out for y. So if I start with -2, it's gonna be so if I start by plugging in -2, simplifying what's inside my absolute value sign first. 2 times -1 is -2. -2 plus 1 is -1. And I still have my absolute value sign. The absolute value sign of -1 is +1. Still have the -3. And 1 minus 3 is -2. So there's one of my points. Now if I plug in -1, 2 times -1 is -2. Plus 1 is -1 again. So I should get the same answer here of -2. So let's see if this is on here. -2 down 2. Wait a minute. This one is. Give me a second. Oh. Whoopsies. Sorry. What I did here was this work right here. This was me plugging in a -1 for x instead of a -2. So scratch that. So I gotta do that again. When I plug in a -2 this time, 2 times -2 is -4. -4 plus 1 is -3. And then the absolute value of -3 is +3, and 3 minus 3 is 0. So my first 2 points, I have -2 comma 0 and -1 comma -2. So that looks to me, let me see if there's any other ones. Definitely not these two. Can eliminate those again because that's going positive. -1, -2 is not even on these two V's. So it's between this one and this one. Okay, so I limit it down. Oops, sorry, I didn't realize you're off my screen. I limit it down to A and B. Now I gotta figure out, is the shading inside my V or on the outside of my V? So I'm gonna use the test point 0, 0. So I'm gonna take this equation and plug in 0 for y, as well as 0 for x, -3 still. Simplifying that. 2 times 0 is 0, 0 plus 1 is 1, and it's still in the absolute value sign for now. Doing the absolute value of 1 is 1. 1 minus 3 is -2. So this says 0 is bigger than -2. That is a true statement. 0 is bigger than all negative numbers. So in this case, 0, 0 is inside the V. The point 0, 0 is inside your V. So that means inside your V should be shaded because it was a true statement. So that means A would be our answer. If it was false, that means the opposite. Everything outside your V, that in this case would have to be shaded. Because if 0 is not a solution, nothing inside your V would then be a solution. So sorry about that. I plugged in the wrong number here at first. So if I look at this page, all of them can use the shortcut except this one because it has a 2 in front of the x. So for this one, you'd have to take time to make the input and output table. For these, you would start by going to the left 5, down 3. That would be your starting point. 1, 2, 3, 4, 5, down 1, 2, 3. And then the number in front is a 2. So I'm going to multiply 1, 2, and 3 by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So at my starting point, I'm gonna go over 1, up 2 on both sides, because I got 1 and 2. My second, I'm gonna go over 2, up 4 from my starting point. And then I could go over 3, up 6. Then from here, you would have to plug in 0, 0 for x and y and see if you're gonna shade everything inside your V or outside your V. If you plug in 0, 0 and it's true, 0, 0 is outside your V this time. So if it's true, I gotta shade everything outside my V. If it was false, then you'd shade everything inside your V. It all depends on where 0, 0 is located. Is it located inside your V or outside your V? So all these you can use that shortcut, except for this one, because of that 2, you'd have to make an input and output table.